Hello and welcome to this video on enlargements. Okay, so in this video we're going to be having a look at how you enlarge shapes using a given scale factor and a center enlargement, and then we're going to have a look at how you might describe an enlargement. Okay, so we've got a little video to show you what an enlargement is. So it's pretty basic bit of terminology really. It's essentially where you're going to make a shape bigger on a grid. So it's a type of transformation, and a transformation, as you may know already, is a way of changing the size or position of a shape on the grid. And with enlargements, we will be doing both of those things. So the position of the shape will be changed, and also the size of the shape will be changed. So to enlarge a shape, a center of enlargement is generally required on most questions. So when a shape is enlarged from the center of enlargement, the distances from the center to each point are multiplied by the scale factor. So for example, on this one here, the shape is 3 times bigger. So the green triangle is 3 times bigger than the purple triangle. So we've got a scale factor of 3, and the distance between the O, the center of enlargement there, and each point on the shape is therefore going to be 3 times bigger as well. Okay, so if we take a look at this then, in terms of describing, so to describe an enlargement, you need to include these things: the center of enlargement and the scale factor, and you would also obviously need to state that it is an enlargement. Okay, so this is the largest type of enlargement that you will the easiest, sorry, type of enlargement that you will see in an exam. So it's asking you to enlarge this shape with a scale factor of 3. So all you've got to do here is make it 3 times bigger. You haven't got a center of enlargement on this one, so you can just draw it anywhere in the grid. So I'm going to go over here. See, so it's going to be, so you can see here it's 1 square for the base here. So on the larger shape, it's going to be 3 squares. And we've got 2 diagonal squares there. So it's going to be, this time, it's going to be 6 diagonal squares for that. So that's going to be there, there, and then up there. It's quite a tricky one, this one, actually. And then same the other side. So it was 2 diagonal squares on the original shape, so it's going to be 6 diagonal squares on this shape. So like this, and then we've got to draw the top in there as well. And there we go. And if you want to check with the top, we've got 3 squares on the smaller shape, so it should be 9 here. 3, 6, 9, as you can see on the top. And that is it. Okay, so we can see on this one then we've got a center of enlargement this time. So we've been asked to enlarge the shaded triangle by scale factor 2, center 1, 0. So the first thing I would always do on questions like this is to mark that center of enlargement just there. And then you've got to look at each individual point now. So if we take a look at this one's 1 across and 2 up. So 1 across and 2 up. So if we are going to move that, it's going to now be twice as far away. So if we multiply both of those by 2, the triangle should now be, or this point on the triangle should now be 2 across and 4 up. Okay, so we're going 1 across, 2 up. Now we're going to go 2 across and 4 up. So the bottom of that triangle is now going to start in this position here. So once we figured out 1 point, all we now need to do is just make the shape twice as big. So this side was was 2 squares or 2 centimeters. So it's now going to be 4 centimeters there for the height. The base of it was 3 squares. So it's now going to be 6 squares along here. And then we can just join together those points just there. And we now have our new triangle that is twice as big and it's twice as far away from the center of enlargement. If you want to check it with this other point here, this one was 4 across and 2 up. Now it's 8 across and 4 up. So you can see that point is also twice as far away from the center of enlargement. Okay, our next example then, it says enlarge the shaded triangle by scale factor 1.5 with the center 0. So they're telling you here that the center is 0, 0. And if we have a look at this base of the triangle, we're 4 across and 4 up. Okay, so 4 across and 4 up. So we've got to multiply that 4 by 1.5. I'm going to write that in pen there, my pencil's playing up. So 4 times 1.5. So 4 times 1.5 is going to give us 6. So we're now going to be 6 across and 6 up. I'm going to get myself a better pencil to draw that. So now we can go 6 across and 6 up. So our new triangle is going to start in this position just here. And everything's going to be 1.5 times bigger. So here it was 2. Well, 2 times 1.5 is 3. So this side of the triangle is now going to be 3. That's the height of the triangle. And then the bottom of the triangle was also 2. So it's also now going to be 3 as well. So now we can join together, make the hypotenuse there, and there is our new shape. So in this part of the video, we're going to be looking at how you would describe an enlargement. Right, so here's our first description one then. So first of all, it's asking us to go from shape A to shape B, and that is an enlargement. And now if we have a look at a couple of the sides on there, so this side here is 1 square. The same side on the larger shape is 2 squares. So we would write down enlargement by scale factor 2. That's going to usually get us 1 mark. Now, the tricky bit here is to work out the center of enlargement. So what you need to do for this is, if you take a look at the equivalent sides on the shape. So if we take this one and this one, we need to draw a line between those sides until we run out of space on our grid, between those, not sides, sorry, points, corners. So we're going there. If we do the same for this one, then we can do the same, I mean that works for that one. We can do the same for this one here as well. What you may notice now is that all of these points are meeting at the coordinate -7, 1. So that is your center of enlargement. Okay, and if you want to check that that's right, if we take a look at this point here, it's 4 squares away from there on the smaller shape. It's 8 squares away on the larger shape. So the distance from the center of enlargement to that corner on the shape, to that vertex, is twice as far away. Right, we're going to end with a slightly trickier question here then. So if you look at what the way the question's worded, it says describe the single transformation that maps triangle A onto triangle B. So we're going from this A to B. So you may notice that the triangle's actually getting smaller, but in terms of transformations, it's still classed as enlargement, which sounds a bit odd because the shape's getting smaller, but it's still classified as an enlargement. Any changing size on transformations is classed as an enlargement. Now, the way to work out the scale factor is a little bit trickier. So we're going from 4 here to 2 here. So you will note that tells you that this is half the size. So B is half the size of A. So that means the scale factor is a half. So that gets you 1 mark on this question. Now the next bit is obviously a little bit trickier, which we've already looked at on the previous example, but it's the same process again. So if we look at these 2 points, they're the equivalent points, and then we need to draw a line from those points. So we run out of space on the grid. Do the same for this one as well. And you can see that all of these points meet in the coordinate, meet in this position, which is the coordinate 5, 6. And if you wanted to check that was right, the new shape is 2 squares down and 2 across. On the original shape, it was 4 down and 4 across. So the distance is now closer. Because we've got the scale factor as a fraction here, it means it's going to be closer to the center of enlargement. Okay, and that's it for this video. So thank you very much for listening, and please hit subscribe if you want to see more videos.